Select the missing starting material required to accomplish the following transformation. So we need to identify what sort of reaction it is that we're looking at. So we can look at the reaction conditions. We say we're bringing together two of the same molecule. So this should make us kind of think about some of these condensation reactions that we've been discussing. And we also want to look at what the identity of the product is. So we see we have an ester and we have a ketone. And that ketone is at the beta position. If this is alpha and this is beta. So we have a beta keto ester. And we need to recognize that this is the product of a Claisen condensation. And since we see the two here, that means we're bringing together two equivalents of the same ester. So whenever we have a Claisen condensation and we have this beta keto ester, so where you see the ester carbonyl and then that alpha carbon, that would have been your attacking enolate, because you're always forming a bond at that alpha carbon. And this would be your new bond. And then you should be able to see the same kind of pattern. So you wouldn't have your leaving group here, but you would still have the same carbonyl and then this carbon chain. So whatever you have there, and then R prime. So you'd be bringing together two equivalents of the same molecule. So if we look at the ester portion, this is where we're going to see what we brought together, right? So we can see we have 1, 2, 3 carbon atoms, and we have an ethyl ester. And we should be able to see there's 1, 2, 3 carbon atoms on the other side. So this means that our starting ester kind of look like that. If we kind of just cut that off, right? So here's the ethyl ester, and that's carbon 1, 2, 3. And so if we look at our options, it looks like B. So here's those 3 carbon atoms, okay? And the only other molecule here that is an ester that could undergo the Claisen condensation is D. So if you wanted additional practice, you could go ahead and try to start with this and do your Claisen condensation and come up with the product. It's really just 1 carbon atom longer, so you'd have 1 extra carbon here and 1 extra carbon here.